So what we're working on right now, real quick, is just a quick review. Someone asked me to graph a cosecant problem, and we describe cosecant as the same as sine, cosine, and secant, where we set up an a, b, c, and d value. All these values are exactly the same as our sine and cosine because we are just graphing a sine or cosine problem, just as a setup. That part has not changed. So d and c are done. That's 0 and 0. Our period is 2 pi over b, just like sine and cosine. So if I'm starting at 0, we're ending at pi away. That's always a freebie. And then we draw a half, half, and half. That's always what we do. This is how I teach it. I always draw my tick marks to show a little bit of good spacing. Okay? And then we have our a values 1, 2, 3, 1, 2, 3, negative 1, 2, 3. Because my d value is 0, we can go up 3 and down 3. Okay. Now, I could draw my dotted lines here, but for cosecant, we want to remember that we're using the framework of sine and using the framework of cosine to graph secant and cosecant. So the framework meaning for cosecant, this is really a sine graph because this was the reciprocal of sine. And secant is the reciprocal of cosine. So we have to go back and remember, I need to graph a sine graph. So here we go. Sine graph is 0, up, 0, down, 0. And you guys can imagine a sine graph forming from that. Man, 2 people already left. Sign in and leave. Okay, so maybe they got dropped. Now, we said the reciprocal of 0 was infinity. So we're going to flip these upside down and make these go to infinity. And these essentially were my Great Walls. Great Walls of China. You can't pass this, okay? So as we go towards 0, instead, we are heading toward the reciprocal infinity. As we head towards 0, instead, we head toward where? Infinity. And these walls are almost like the walls outside the zoo. They keep you in. This way, it doesn't go up. It doesn't go up, okay? Because if I went up, I'm going to go ahead and flip it, and the reciprocal takes out in the other way. As the sine graph does continue, 0, up, 0, down, 0, the pattern continues. Instead of going to 0, we go off toward infinity. Instead of going to 0, we go off to infinity. In this case, negative infinity. So the goal is to first graph that sine graph in your head, and instead of going toward 0, we take off away from 0. 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 Well, please don't draw that sine graph in the middle. Yeah, that's it for the graph. So our sine graphs, once again, go toward 0. Our reciprocal graphs go, instead of toward, they go away from 0. To off to infinity. And this does lead to today's graph, which is today's graph we're doing tangents and cotangents. So cotangent and tangent graphs. So these graphs are looking quite terrible. So let's go ahead and take a look at Desmos, what these graphs look like. Oh, come on. So I go to Desmos. I don't have Desmos, do I? Nope, let's go ahead and go to Desmos. Here we go. I'm going to graph tangent of x. Tan of x. And you take a look at it, and it's almost like a bunch of s's. Right? And what I want you guys to notice is that we are still going off to infinity. See, we're still shooting off to infinity. That number is going forever. Whoa! Like SpaceX rockets into the sky. And we're still going to infinity, negative infinity here. Okay? And there is a separation between each of these spaces. And we're going to talk about that right now. So these graphs, tangent and cotangent graphs, might seem looking very difficult. But just like when we started looking at sine graphs and cosine graphs, those also were very difficult when we first started. And we just realized there's a pattern to graph this. And there's a couple of steps that we want to make sure we cover. So that's what we're going to do today. We're going to cover our steps for graphing tangent and cotangent. So just like before, our tangent graphs have the same form, a bx minus c plus d. So our tangent graphs and cotangents still have our a, b, c, and d. That has not changed. Again, this has not changed. We still have our a, b, c, and d. So if I write y is equal to, that's use number 2, tangent of x. Let's go ahead and start here as we first start. Okay, a is equal to 2, b is equal to 1, c is equal to 0 and d is equal to 0. Now, I want to show you the difference between tangent and cotangent graphs right away. First, the big difference. Here is my tangent graph. Whoops. And then let me show you what cotangent graph looks like. So cotangent graphs look like tangent graphs, except they go the other way. And please take a look here. I'm going to draw you something. A tangent graph is going to go between, I'm going to write it here. X equals, I'm going to do something here. B. Yeah, let's do this. We'll call this little b here. We'll add a slider for b. And then I'm also going to say it's going to be b over 2. Nope, sorry, 2 pi b. Pi divided by b is my period. I'm going to divide this by 2 Okay, I'm going to change one more thing here. Okay. And we are going to pi divided by b on one side, 2 pi divided by 2, and then we're going to divide this answer by 2. Dang it. Sorry, my mistake. Okay, sorry. For some reason I messed up in my brain. Okay, that's a 2. And then next here is going to be x equals to pi divided by 2b. That's where my mistake was. Okay, I'm going to do one more thing here. Change these colors to blue and dotted and blue and dotted. Okay, so we have vertical asymptotes, as you guys can see in blue. And those happen at pi over 2 and pi over 2, negative pi over 2. And I'm going to show you cotangent real quick. And cotangent doesn't fit within these borders. Take a look. See, cotangent is not within the borders. And we'll talk about that in a little bit. But the graphs are off center. They're skewed over to the right. But what I want you to notice is that first, tangent's going to be 50-50. If I consider 0 the center of my graph, tangent is half on the right and half on the left. It's almost like it's a BTS band, right? Half on the right, half on the left, and they're going to start to dance, okay? I also want to include one more letter here. I'm going to include an A there. And then we will show you what A does, okay? Okay, here we go. So here is the big difference between here's a big difference between our period for sine and cosine. So for sine, cosine, secant, and cosecant, our period, it was 2 pi over b. But for tangent, our period is not 2 pi, it's going to be pi over b. And that is the big difference. For tangent and cotangent, please keep note of this, that the tangent, cotangent, the period is pi over b, not 2 pi over b. So this will repeat every pi, essentially. So let me go ahead and start graphing these out. First we say d is 0 and c is 0. So we're going to start on 0. And then the period here, that's right, it's going to be p is equal to 2 pi over, what's my b? Not 2 pi, dang it. It's not 2 pi, it's just pi over b, which is 1. So it takes us pi to finish the graph. Now, here is something you need to catch. We said that tangent is like a BTS boy band. half on one side, half on the other. Okay? This is the idea, half on one side, half on the other. So if it takes me a full pi to finish, we actually have to split this in half. Half on one side and half on the other. So what is half of pi? Half of pi is pi over 2 on one side and negative pi over 2 on the other, because we want to take one full pi to finish this off. Now this graph is going to be somehow squeezed between these two lines, right? It's going to be some weird S shape, but we're going to take pi to finish. Whoa, come back. No, I tapped it too many times. All right, so first thing we do is we make sure we have our period done. We said it takes me 2 pi over b, so pi to finish. So we do 50-50, 50-50, right? Cut this in half, 50-50. So tangent graphs is what I call 50-50. Half on one side and half on the other. Now, if you remember for our period, after we do our period, we do half, half, and half. We still do that here. So between the left intercept, the left asymptote and the right asymptote, we still do half, half, and half. Trust me on this. This is super important because it helps me space out my graph. And it gives me how sharp my graph is going to be. Because my last step, my amplitude, just like what we did before, let's graph the number 2. It's this. At the quarter marks, we go up 2 and down 2. So up 2 spaces and down 2 spaces. If this was 3, we would go up 3 spaces, down 3 spaces. And why is this important? Because this gives me my next checkpoint as I graph. So the way we graph a tangent graph now is we do a parabola. On the right side, we do a parabola going up and a parabola going down. And that is our tangent graph. Now I want to show you this on Desmos to see that you notice the values that we chose. So on Desmos, oh my gosh, you reset it, did it? Oh gosh. That's great. Okay, so if I write again, I'm going to use the letter A this time. A tangent of x. Okay, add a slider for A. I want you to notice, let me go ahead and just write it. X equals to okay, I just want to make sure we have our borders here. These are asymptotes. Okay. And I want to also show you our quarter marks. This is our quarter mark here. If you look at our quarter marks, not fine, I'll write it. Our quarter marks is going to be pi over 4. That's our quarter mark. Turn it. So I want you guys to notice this here. If you look at it, at the quarter mark, our value is 1. Why? Because our A value here is 1. A value is 1. So our quarter mark is going to be exactly at 1 here. What if my A value was 2? If my A value was 2, looking at my quarter mark, come on. See how now this is 2? My quarter mark is now 2. If my A value was 3, let me change one setting on this. I want step 3. Oh, step by 1. I'm sorry, wrong one. 0.5. So if I go to 3, my quarter mark is up here at 3. On the left side, at my quarter mark, let's copy this quarter mark. Let's stick a negative there. On my left side, we said my A value is 3. We're going to be all the way down here at 3. Where's 3? Right here, see? Follow it up, follow it up. That is at negative pi over 4. Our quarter mark, we're going to be at negative 3. So why am I bringing this up? Because these graphs are actually really easy. I'm going to graph this one more time. Here we go. Graphing my 2, my pi, my C and D are both 0. Let's do this one more time. Since this is a tangent graph, this is a 50-50 graph. That means half on one side, half on the other. How far do I go? Am I way over here? Am I over here? Am I over here? What we do is we say the period first is pi. So we don't go 1 pi out. That is wrong. We go 50-50. If it's pi over all, I do pi over 2 on one side and negative pi over 2 on the other. Okay, if the overall period is pi, tangent is 50-50, so we do half on one side, half on the other. After we do our period, we do half, half, and half, right? That's our half, half, and half. And the amplitude is up 2 on the right and down 2 on the left. This is our BTS boy band. And remember, tangent starts right in the middle, 50-50, right in the middle. So on the right side, we graph going up, and on the left side, we graph going down. What if this graph was 1/2 tangent of x? What if the only difference was the amplitude? Well, just put the a value 1/2. See, sorry, that's not 1/2, that's 1. 1/2 would be like right here. 1/2 would be like right here. Are you guys okay with seeing that as 1/2? So how would this look? It would be squishing it. Yeah, I'm going to squish this bug. It would be squished down. It would be squished down. What if this was 3 tangent of x? At the quarter marks, we would be at 3. At the quarter marks, we would be at, in this case, -3. Okay? And we would, 3 tangent of x. So we go to 3, and this would go to 3, just a little bit faster. So that's the biggest important part of our period and our a value. Our period helps drive our quarter marks, and our quarter marks help drive our amplitude. Okay, let's do this one more time. So tangent, let's do 1/2 tangent of, let's do 1/2 x, okay? A is equal to, we'll do +1 here too, +1, yeah, +1, let's go. A is equal to 1/2, B is equal to 1/2, C and D, C is 0, but D is 1, and we graph like before from D, C, B, A. So what does D do to my graph? If you remember, that's my vertical shift. So the graph is now 1 space up, call that 1. So the graph got moved up. All right, moving up in the world. My C is 0, so we're starting at 0. Since this is a tangent graph, we're at 50-50, okay? 50-50. So what's the period? Period is pi over b, which is multiplying by the reciprocal, 2 over 1, which is 2 pi. So if it takes me 2 pi to finish the graph, and this is 50-50, how much would be on the right side? How much would be on the left side? Well, pi over 2 is pi, so if we're negative pi on one side and positive pi on the other, that takes us a full 2 pi to finish. My table is a little off. That looks better. After we have this full length of the graph, we do our quarter marks, half, half, and half. Just get this nice and separate it out. If you want, you can draw the vertical asymptotes. That would help you realize, oh, there's a force field here. I'm going to block out the rest of the graph. Okay, I'm going to copy my tick marks up to my D value. Now, only one last step. The last step is our A value. Our A value is 1/2. So my amplitude at the quarter marks is going to be 1/2. Take a look here. I pick 1/2 up and 1/2 down. 1/2 up from my quarter mark and 1/2 down from my quarter mark. This graph is going to be squishy. Squishy, squishy, squishy. But it's going to be nice and balanced on both sides. If you want to say, go, but what if I want to draw another graph? What if, doesn't sine graphs, for instance, go over and over and over and over? Well, we can do that here. If my last value is pi, and it takes me another 2 pi to finish, so what is pi plus 2 pi? That takes us all the way to 3 pi. And if 3 pi over here, it is my next graph. To space it out, we also do half, half, and half. Half, half, and half. Just make sure I have that nice spacing. half, half, and half. We follow all our same values from before, half, half, and half. A tangent graph means 50-50. That's why we're half on one side, half on the other. Well, how steep is it? Our A value says it's only half. So it's not very steep. It's actually pretty squished. Pretty squishy. Look, they're like twins. Okay, pretty squishy. So how does this change for cotangent? And cotangent almost follows all the exact same steps, except we have to remember two critical things. So for cotangent, what's the difference between sine and cotangent? Let me go ahead and draw you guys a cotangent here. It's going to be a cotangent of x for anything else. A cotangent. So what's the difference? Is the cotangent graph, instead of going up, it goes down. That looks so weird. Look, they're all dancing next to each other. Whoa, Mr. Co. It's like wallpaper. Let me change this color. I'm going to change the color to, let's see, we'll use green. No, what? Green will be colorblind. Okay, I'll use orange, I think. I think that's orange. Okay, so if you take a look at my cotangent graph, instead of going up, it goes down. Instead of going up, it goes down. And instead of being right in the middle, it's going to be shifted over. So I'm going to show you guys what I mean by the shifted over part. It is flipped around. It is. And it's also shifted over to the right. They're not on top of each other. They are shifted over. So here's what I mean by shifted over. I'm going to recall the same thing. Let's say 2 cotangent of x. Okay, y is equal to cotangent of x. We do a, b, c, d. A is 2, b is 1, c and d are both 0. Looking at the characteristics. Now, as I draw my graph out, d is 0, c is 0. Now, here's what I want to tell you. Cotangent isn't 50-50. It's 100%. Just like sine, if I tell you the period here is pi over b, pi over 1, it means if I start at 0, we're going to go all the way to pi. This is my full length of the graph. I'm going to take one full step pi to the right. So the graph is going to start at 0 and end at pi. That's my vertical asymptotes. That's my null zones. Whenever we do period, we always do our spacing. Half, half, and half. Half, half, and half. Please notice, just like before, we did half, half, and half. We're always doing half and half and half because we have all these points we have to hit along the way. And half, half, and half gives us a nice spacing. Now the graph starts in the middle. Now here is where the amplitude plays into play. My amplitude, it's 2 spaces up and 2 spaces down. But we said it's going down this time. Okay, down this time. But to be more accurate, we have to make sure we hit our points. It's going to be amplitude 2 and 2. So we're going down, and you use the amplitude 2 here and negative 2 here to make sure you have a nice graph. So parabola going up, parabola going down. Now, oftentimes you want to see this on both the left and the right side here. Right here, we only graphed on the right. What about the left? Well, it's the same thing. If I make the period go this time to negative pi, because that's the length of my graph, pi, half, half, and half, like what we did before, we just follow our amplitude going down. The amplitude going down. Amplitude going down. So what's the only difference between cotangent and tangent? Tangent goes 50-50. This is a tangent graph. A cotangent instead takes a step to the right and goes down. So it's 100% to the right and 100% to the left. Okay, what else can I say about this? So let's graph one more time with cotangent. Y is equal to 2 cotangent of, we'll do 1/2 x. So very similar to what we did before. And we'll say plus 1. Yes. So A is equal to 2, B is equal to 1/2, C is 0, and D is 1. Are you guys okay with this C value, hopefully? No parentheses, no C. Graphing, starting off with D. Here's my D value, is going to be 1. So we know we raise the graph up by 1. What is my period for this? Why don't you guys come up and try to come up with the period? What's the period? Is the period 2 pi or is it pi for cotangent? For cotangent, it's pi over 1/2 multiplied by the reciprocal. Pi times 2 over 1 is 2 pi. Now, for tangent, if this was tangent, this would be 50-50. Pi on one side and negative pi on the other, because we want 2 pi overall. But this is cotangent, and cotangent, it's cool, Faith. It's going to be all the way. You give me 100%. 100%, sorry, that's not 100%. That's going to be my whole 100% is 2 pi. That's my full period on the right. If I want to go to the left, that's a full period to the left. That's negative 2 pi. Half, half, and half. Half, half, and half. Don't forget to copy these tick marks onto my d value. I'm going to draw my asymptotes here to say, hey, don't pass that. Now the last part, our a value, is cotangent rising or falling? Remember, Mr. Co makes you feel terrible, right? So if you could go on a tangent, if you get Mr. Co on a tangent, great. If you can, but you haven't Mr. Co, oh, so sad. So sad. But how steep is the sadness? That's where our amplitude comes into play. 1, 2, we're up here. Down 2, we're over here. So from our center, we come down and we go up. On my left, remember we're coming down, so it's 2 spaces and 2 spaces by amplitude. From the center of my graph, please. From the center of my graph, down and down. And that's it. That's the only 2 new graphs that we have to cover, tangent and cotangent. They follow very similar moves to us graphing sine, cosine, secant, cosecant. We still do A, B, C, and D. We still draw all the characteristics, except, of course, it's a little different now. With tangent, we do 50-50, and the amplitude is at our quarter marks. For cotangent, we give it our full 100% for our full period to the right. That's our full period. And then we still do half, half, and half. And instead of going up, we go down. What if the amplitude was negative? What if I wrote negative y is equal to negative 2 cotangent 1/2 x plus 1? What would happen to this graph? All your negatives would be positive because we would be flipping the sign, and this would just be the same graph going up now. That's the only difference. By putting a negative in front, we just flip the graph completely upside down. Okay, that's it.